What are we getting right? What are we getting wrong? Where's your position on all this?
Well, I'm a climate scientist, and the position of the scientific community is unanimous, and that that is happening. And that's the thing about science is we go out and we look for evidence. Scientists don't tell anybody what they need to do. We go out and we gather the data and say, this is what's happening. Now you make that decision yourselves. And so, yeah, politicians are going to politic, right?
Yeah.
Activists don't have, if you don't have a scientific background, which most of the people on the anti-climate change, I just don't understand how basic science is done. I mean, I've been to Mauna Loa, where the Keeling curve was discovered. Where the CO2 emissions, that graph where the CO2 emissions. We've been taking the same measurements there for 50 years. I've been to Station Aloha, which is, this region in the middle of the ocean, 100 kilometers northeast of Oahu, and we've been going there month after month on research cruises for the last 30 years, taking the same exact measurements and watching the change. There's no room for fiat to come in there and put their
the dirty fiat fingers,
the fiat fuels. Like, do you mean you mean petroleum? sorry, I've been reading too much of this book that I don't want to talk too much about.
Well, now I want to know what book.
Is it not clear to you after that?
Is it Fossil Future?
No, it's Safe. It's Safe's book.
Which one?
He has a chapter called in the Fiat Standard called Fiat Fuels.
I haven't read the Fiat Standard. I read the Bitcoin Standard. Has some good bits and
some good bits. Yeah,
absolute bullshit.
I look at it as like a parable. It tells a good story, and the moral is there it is.
Okay,
Mauna Loa Observatory.
We'll come back to Safe's book.
The Keeling curve. This is
what is this? Explain to the people listening who can't see the chart.
That's the carbon dioxide concentration from the second highest mountain on planet Earth. So far removed that there is no human impact on that. It's so high up that there's no, crosswinds coming from, LA that are diluting it. This is the heartbeat of the atmosphere, and the Station Aloha Observatory is the heartbeat of the ocean.
So from 1960 to 2015, so in 55 years, it's gone up about 30% in a pretty straight. It seems to be just slightly.
You can see the jagged line.
Yeah.
That's the difference between the summer and the winter. There's a lot more land. In the northern hemisphere, right? You look at a map, all the land is in the northern hemisphere. And so, when we burn a lot of, fossil fuels in the wintertime for warmth,
right,
higher. And then when when it shifts to summer, it goes back down because the southern hemisphere uses a lot less.
And I'm assuming there's other people doing these readings all around the world.
All around the world. And they all say that, and it's not just these numbers, this is just CO2. This is just this is kindergarten shit. You take people up there and kindergartners do this on field trips, right? People make a pilgrimage up there, high school students, middle school students, they can all make this measurement. The real measurements are actually the delta 13C, the isotopes. And that's really, this is that's just straight carbon dioxide, but it's the isotopes, the isotopic record that really has that fingerprint of humanity, because, not all carbon is the same. There's different flavors. Carbon 12 is the one we know the best. It weighs 12, right? All carbon has, 6 protons. The amount of neutrons is kind of arbitrary, right? Not all, isotopes are stable, but of the stable isotopes, carbon 12 and carbon 13 are the most important. 13 obviously has, 6 protons, but 7 neutrons. So it weighs a little more. And it turns out that life, things that are living, that makes a big difference, right? The energy required to form bonds with carbon is proportional to the weight. Imagine walking around with a backpack, an empty backpack, your carbon-12, and then sticking a bunch of bricks in your backpack. That's carbon-13. Which one are you going to prefer? If it's between you and Danny, who gets to wear which backpack and have to walk around for the rest of your life?
To be honest, Danny's been carrying me for a long time.
So he's carrying you and the backpack.
Yeah, so I probably owe Danny one.
Carbon 25.
And so, fossil fuels come from, living matter, right? I remember it. Oh, God, I was listening to one of the interviews that was Safe and Alex, and they were talking shit about wetlands and swamps. And it's like filthy swamps. Like, where do you think fucking coal comes from? You dingleberry? Like, where does coal come from? It comes from swamps. Like, 300 million years ago, but fucking swamps. And so, those plants that lived in the swamps, disproportionately uptake that lighter carbon over the heavier that carbon-13. And so they took up that extra carbon, and then when they got buried, they took it with them. And so that changed the isotopic content of the CO2 in the atmosphere, and we can measure that. And so now what we're seeing is, that isotopic content, that delta C13 ratio, shift down because we're putting that that lighter carbon back into the atmosphere, and that's the fingerprint. It is unambiguous. It is humans putting that in. It's not rocks, because rocks don't give a shit, right? Rock don't care. Rock do what rock do. Geology is geology. There's not much art in geology. This is a rock. It's gonna do the thing that a rock does. Life is weird.
All right, so we're definitely increasing the carbon in the atmosphere.
Yes.
That is unambiguous.
Yes.
And you can't debate that. But does having more carbon in the atmosphere definitely change the temperature?
Yes.
Tell me how. Like, I'm being the doubter here. Like, I believe you.
So carbon dioxide, right? 1 carbon, 2 oxygens, right? This is it's a linear molecule because there's a double bond. How deep do we want to go into the science?
Have you got to go anywhere? We should have got a bottle of whiskey.
There you go.
That's what we should have done.
I can go right now. 3 blocks away.
You can go. We'll carry on.
Scotch.
No, fuck that shit. I'm a bourbon guy. I can't drink scotch.
If they have Talisker.
Exactly. Notes of red pepper.
All right, let's get some whiskey on. Let's go.
But no, carbon dioxide's a linear molecule.
Do you know why I care? It's because, like, I don't retain knowledge well. I'm more creative, right? My entire career has been creative, storytelling or getting people to tell stories. This is why I can never remember what the fucking X-Pub is, because I can read it, I just don't retain the knowledge. And I'm always reading about climate change and seeing, and trying to understand it and reading the scientific papers, but I don't retain it. But I'll have someone like Alex on my show, and I just don't have the ability to debate him correctly.
Right.
But I do want to give him the time. So therefore, hearing from you and having you explain it, I mean, I should just get you to sit down with him and have a conversation.
Well, I'm supposed to debate someone. They're not. They're being little weasels.
Who's that? Is it Safe in?
Yeah.
We'll get to Safe. Oh, God. We'll talk about Safe in a bit.
So carbon dioxide is a linear molecule, because there's that double bond between both, the carbon and the 2 oxygens, right? And so there's different modes of freedom, and, it can wiggle, right? So when you and it likes to wiggle at a very specific frequency. Think like a guitar string, right? You tighten the guitar string, and it makes the same, the D or the G or the A, and it's based on the wiggle. So different bonds have different wiggles, and they like to wiggle at that one frequency, right? So when something strikes it with that same frequency that it likes, it responds, right? And in general, the one that really matters is the twisting and the bending. There's symmetrical and asymmetrical, but those aren't necessarily super important. But the major one happens to wiggle in the IR frequency, infrared radiation frequency. And so what a lot of people don't understand is that the heat that we feel here at Earth on the surface is not directly from the sun. It's actually, the sun strikes the Earth, and black body radiation says that, that the Earth will then re-radiate that energy that it's given. So, the sun is very hot, so it has the frequency of the energy comes off of it is a lot shorter wavelength, and when it strikes the Earth is much cooler than the sun, so it has a longer wavelength in the IR spectrum. It turns out that that wiggle in the CO2 and of course in methane and all the other greenhouse gases, right? They all take up, they all like that general, they all absorb energy really well in that range that the Earth puts out. And so, as the Earth radiates the energy from the sun back up, well, the carbon dioxide absorbs that energy, which is supposed, going straight up, right? If it was, if that carbon dioxide wasn't there, that energy would just fly straight up, right?
Right.
Because the sun hits the Earth and the Earth radiates in a, circular, away from the circle.
So we're just retaining the heat.
And now that's a good thing too, because if that carbon dioxide wasn't there, it'd be like minus 19 degrees Celsius all day long.
So we need some. We need a balance.
Yeah. And so it's about how much. And, what it does is it just keeps filling up. It keeps where that carbon dioxide is, it slows that energy transfer down because the Earth has to radiate the same amount of energy it takes up. It has to re-radiate that to space. Otherwise, of course, we'll boil. And so what more carbon dioxide does is it slows that transfer of energy down. And we can, of course, record this from space by looking, just taking a spectrometer, saying, hey, this is what the sun's putting out. Hey, this is what the Earth is putting out. Turns out we're about 5%. We should be, in order to get that, kind of static where we're putting out as much as we're taking in, we're about 5% lower than that. And so that's where the energy, and it keeps going up and up and up and up. And that means there's more heat here. We're just retaining more heat.
Which means polar ice caps melt.
And not just, that's only one component of sea level rise.
Mm-hmm.
So, the density of water is dependent on its temperature and salinity. So
when it's warmer, it expands.
It's warm, it expands. So the polar ice caps, if they all melt, it's like 30 feet of sea level rise. If at that same temperature where they all melt, well, the
water's expanding,
yeah, it's 300 feet. And what's cool about living in Hawaii is we see this all the time. We can, there's a number of hikes that you can do where you can just look up 300 feet and go, oh, that's a bunch of fucking coral in the air. Huh. Because the sea level was hundreds of, and that would be devastating to all life. It's like we were, talking about before with the Mississippi, right? If the Mississippi River was allowed to shift, that would just completely fuck over our inland transportation network, using the rivers, the navigable rivers of the U.S. Well, a 300-foot higher sea level would devastate our ability.
300 or 30?
With thermal expansion of the ocean, we're talking 300.
Hold on.
So
how much habitable Earth is left after that point?
A lot.
Yeah.
It would push in. Obviously, Florida's gone.
Yeah.
Yeah, Florida. Who needs it? I lived in Florida for a while. I like it. I lived in the Keys. I like it. I'm not going to talk too much shit about Florida.
But we will lose a number of nations.
Yep.
Okay.
Yep.
And
low-lying Pacific nations, which are a big deal.
Yeah. Okay, so that is one. But there's numerous issues with climate change that come. So when you see this discussed within the Bitcoin community, I'm no good as somebody to debate this. I don't have the expertise, but I feel like we are sometimes shooting ourselves in the foot with trying to expand Bitcoin into other communities when we get this so fundamentally wrong. And you're saying we're getting it fundamentally wrong.
Yeah.
Yeah. So what should be done though? Because okay, you flew over here, you
Yep.
got on a plane, you're in a car,
Yep.
yada yada, and I'm the same. I'm a complete hypocrite. What should and can be done? Like, what is the conversations within the circles you're within? Because it's very clear that there are issues with solar and wind. Yes, they can support and add to the mix, right? But there's clear issues.
Yeah.
There has been an issue with the green lobby essentially destroying the nuclear industry, but
Yep.
but also you said that's finite. So like,
Oh, don't get me started. I'm not a fan of the Sierra Club. Not a fan of Greenpeace. I mean, these guys are all on the take.
so what can be done? Like, what should be done? What
That's the question we need to ask ourselves as the human race. What should we do? Because if doing nothing leads to billions of death, and doing something leads to a billion deaths, what is the right answer there?
a claim of 1 billion deaths is something somebody would jump on you for and say, hold on a second. What evidence do you have that this will lead to 1 billion deaths? We've had lots of claims before in the past that haven't come true.
Yeah.
And that's an issue. So are you just saying that as a pass away comment, or do you actually believe that will happen? Because
you have to define the timeline, right? So what is the timeline for those deaths? Now that's something I'm not going to,
But what causes those deaths? Because if climate change
breakdown in supply lines, food production, water, just straight up flooding. What happens when 1 billion people at the coasts need to migrate? Where do they go? How does that affect your nation? I mean, I know in the U.S. There's a huge anti-immigration. Well, what happens when there's 1 billion people knocking on the doors? I mean, at least China built all the ghost cities that they could put people in. You look at the distribution of land on planet Earth, it's all in the northern hemisphere. And so if the vast stretches of the equator become uninhabitable, where do those 40% of all people live in the tropics? 40% of all humanity lives in the tropics. And if we start fucking with the water cycle, and if we start fucking with where they live and their land gets flooded, where do they go? And the only answer is they go north.